Right. So let's get started into the concept of Docker and Kubernetes. So one thing I just want to share with you is that we see in your perspective, again, these words I have said in the last session also. I'm saying you the same words in this session also. In your perspective, these are maybe a demo sessions, but in my perspective, we are straight away jumping onto the concepts. I don't have any another thing like repeating the same concept for the demos, repeating the same topic, same topic, same topic. I don't want to do that. Of course, you might think that the new whoever are the new joiners, they might think that we may lose any concept. But the point is, uh, these are the very basic and fundamental concepts that we are discussing right now over here. And even though if you are taking up, you are going to lose some concept. So you can get the videos of that either from the YouTube or else like these three demos will be uploaded into the YouTube and as well as videos will be available with the DURGASOFT. You can ask them. So this is the first thing. And the second thing is even though if the videos are available, but nothing can give you an experience that attending a live interaction session. Okay, so don't use these sessions. Okay. Now coming back to the point, we are about to discuss about the main content, main theme of Docker and Kubernetes. So first of all, let us discuss one by one slowly Docker and Kubernetes. Okay. So now what we are going to discuss, what is that, what is the few concepts that we have to understand in the beginning. So first you need to understand web three-tier architecture. Everywhere it is going to start, like everyone, whoever are starting the concepts, they are going to discuss about this. Let us see how we are going to interlink this web three-tier architecture. Did anybody have an idea about this web three-tier architecture? Anyone? Web three-tier architecture or three-tier architecture? See, any web application which we are configuring, which we are deploying, will have the three major components. Okay, any web application, that is the web web type, or what I can say, this is the front end. Okay, front end, and the next one is application type, or else I will call it as a runtime. Okay, runtime, or what I can call it as what are the tools that we are using to run the proper application. So the front end will be written in the either it might be written in HTML or else React. Okay, so there are another tools are also available, but basically HTML, Bootstrap, CSS, JavaScript, and React. By combining all these things, we are going to write the front end. And when you come to the app type or else the application type, the actual programming comes into the picture. The actual coding will comes into the picture. Of course, the front end also will have the coding, that is HTML coding, CSS coding, and JavaScript coding, or also the React JS coding, and everything will be there. But the point is, when you come to the application tier, the actual runtime, so how the application has to behave. So in the front end, what we will do, we will create a very user interactive graphical interfaces, and you will have the sign up buttons, login buttons, and then you will have the sign up form, login form. Like that, you will have so many different kind of things. So when you pass the data, or else when you are trying to hit some button, so that functionality should be working. What is the meaning of that? For example, I go to any banking website. For example, there is KVB. Okay, so KVB Karur Vysya Bank, where you will have the internet login functionalities here. This is the front end. So the user who is directly interacting with the application, who is directly connecting to the GUI in the sense GUI, graphical user interface. So that is the front end. So in this front end, you will have so many different kinds of options that are available. So many different tabs are available. Now, when I click on this personal and when I click on the deposit, it will have one functionality. It is going to take me to the one functionality. So this is called as a landing page. By default, when you see here, when I click kvb.co.in, this is the landing page where the user is getting the attention towards the particular website for the first time. Okay, so that's called as a landing page. Now, in this landing page, you will have multiple options are available, multiple buttons are available. So each and every button will have a functionality. Who will decide that functionality, or else who will create a logic for that functionality? So these are all the things that can be done by your application tier. So this application tier will have Java related programming, or else Python related programming, or else .NET related programming code. So like that, you will have multiple programming codes are available. And the next one is a database type. Okay, database type. So in this database type, you will have the backend, or also what I will call it as databases, all your databases where your data is going to be stored, and whenever you want, it is going to retrieve your data. So the user creation, the user retrieval, user deletion, and as well as whatever the user makes any deposit, the amount which he has deposited, there will be multiple relations will be there, multiple tables will be there, one table will be related to the another table. So these are all called as relational databases. So the backend will be having mostly the relational databases. Nowadays, we are having no SQL databases also available. Okay, so like DynamoDB, Cassandra. So these are all comes under the no SQL type of databases where there won't be any proper structuring won't be there. For the databases, there won't be any proper structure. But when you come to the relational databases like MySQL, PostgreSQL, MSSQL, Oracle. So these are all having a proper structural data, proper rows, proper columns will be there. Each and everything will be defined in an order that this particular column belongs to init. So what I can say, integer, and this particular column belongs to string. This particular column belongs to character. So Boolean characters like that. You will have so many different kinds of columns will be available, and each and every table will be interlinked with each other. So that is called as a relational type of database. So now when you see the backend over here, in the backend you will have mostly MySQL, Postgres, MSSQL, MSSQL in the sense Microsoft SQL and Oracle. And later on, you will have Amazon Aurora will be there, MongoDB will be there. Like that, there are different kinds of databases that are available. But basically, we will use these four. So I'm just concentrating on these four things. Okay, so with the help of this Web3 tier architecture, a web application will be designed. So this is a web application which we are going to design. So you can ask me, sir, every web application will have these three types. Mostly every application will have the three types, but a few application which doesn't need to store any data, then they don't need any databases. But 90% of the applications definitely will have the databases. So this is a Web3 tier architecture which you are seeing here. So now the point comes to here is how this Web3 tier architecture will be available. I mean, how this web application will be available for the end customers. Before I go into the concept, do you understand this Web3 tier architecture? Any questions over here, guys?
Yeah.
At least
No.
say
Yes.
yeah. At least say yes on your chat box, or else at least you can unmute your mics. You have that option. You can just directly interact with me. So do you understand the concept over here? Any questions?
No. No questions.
Right. So now let us discuss about how this web application is deployed. Web application is deployed in the sense, see, first of all, if you want to access this website, let us suppose then I want to access this KUBERNETES Bank website, or else I want to access ICICI Bank, or else I want to access an SBI Bank. How I can access those websites, or else how I can access those web applications. So you need to understand one thing. If a web application, or else if an application is there, okay, so that application need to be installed on any one of the device. For example, in your mobile, you will have certain games will be there, gaming applications will be there. So they will be downloaded from the Play Store. So how they will be downloaded? The mobile developers will upload the code into the Play Store, and from the Play Store you will download it into your mobile, which means there is a storage space, there is an installation object on which you are going to run that application and access the application. In the same manner, if this browser, so browser is just an access point for the end user. Okay. So he want to access an web application. He will give just an URL. So like I have given kvb.co.in, there is icicabank.com. So when I give this, it will be going into the ICICI landing page over here. So in such fashion, when I give a domain name or else when I give an URL, automatically it will be fetching me that particular web application. How it is going to fetch out that particular web application? This web application will be fetched out with the help of what is going to happen. So here I am having a client laptop, and on the client laptop, what I am going to do, I am going to type the URL like www.icicibank.com. When I hit this, automatically what is going to happen? The request will be traveling over the internet. The request will be traveling over the internet. And what is going to happen here is it is not directly going to hit it is not directly going to hit the web server. Okay, as I already said you, for example, this is the location where you are having all your servers. Okay, so this is the conventional architecture which I am trying to explain you. So from the internet, the request will be hitting onto the proxy server. There will be a proxy server, so like Nginx proxy like that. So this proxy server will forward the request towards your web server, and that web server will give you the response. Okay, initially you don't need to save any data. So it will try to hit onto the web server. Okay, so there will be, this is the web server which we are going to configure. It is going to hit onto the web server, and from the web server, you are going to get the particular web page. Okay. So now, what is going to happen when you give the domain name? So the computers will not understand the user understandable language. Computers will only understand the numbers. Okay. So this particular ICICIbank.com, whatever the domain that you are seeing, that will have IP address. Okay, so through the IP address only it is going to reach to this Nginx proxy server or else any proxy or load balancer servers. Okay, don't get confused about this. If you have any questions right away, you can ask me in the chat box or else you can directly unmute yourself and ask the questions, but don't sit idle. Try to understand the concept. Okay. So when the request hits onto the proxy server, and from the proxy server, it will be reaching to your web application. Okay, web app or else web server. I will call it as a web server. So from the web server, what is going to happen? Whatever the data code or else whatever the application code is there, that application code will be taken back to the user. Okay, so and it will be displayed in the browser. So that we all know about this. So now when the user provides any data, so then what is going to happen? That request or else that data will be collected in the web server. So from the web server, the data should be transferred or else the data will be pulled out by another server called as an application server. So this application server or else the application, the runtime, whatever the Java application or else whatever the whatever the Python applications that you are creating, so those runtimes will be installed on a server called as app server. So this app server will fetch out the information from the web server. Okay, fetch out the information from the web server, whatever the user has given. And when he click on submit or else when he click on login or when he click on sign up, anything. So that request will be taken by the application server, and the application server for whatever the request that has been taken, that will be forwarded towards your database server where we are going to store the data or else where whenever the user requests any data, the data will be retrieved from the database. So this is how the web 3-tier architecture is going to happen. Okay, this is how the web 3-tier architecture is going to work. Now, when this Web3 tier architecture is working, see how many types of servers you want. So you want if you see in the on-premises environment, only in the on-premises environment, I require a proxy server. So just forget about the proxy server. If there is no proxy server, we have a load balancer configuration, that's fine. So we need to have a web server, we need to have the application server, we need to have the database server. Sir, can't we create all the three servers in a single server? Yes, we can create them. So what is meant by a server? Can anybody tell me what is meant by a server over here? What is a server? Basic
It's
question for a
something that
computer.
provides service.
A server is a machine which will provide the services to the end customers, right? So which type of services? Any kind of service. Either it might be a web service or else it might be like web application service. So for the web services, you are having like Tomcat, Nginx, IIS, like that. There are different kinds of web services that are provided by the servers. And this is what a server is all about. So inside the server, what you are going to have, what are the things that you will have inside a server? Obviously, server is also a computing device. Okay, so if you see a calculator in a hand, so there is a kid. So in the hands of the kid, there is a calculator. Calculator is also a mini computer, which is going to do a basic calculation. So that calculator will have the CPU and RAM. And when you come to the desktops, okay, or else when you come to the laptops where you are working for your projects, so in your laptops or in your desktops also you will have the same CPU and RAM. So, but when you compare with the calculator, if you are taking your desktop, that will be having a little bit higher configuration. In a calculator, you might be using 8086 processor or also 8088 processors like that. Okay, 80 processors you will be using, and only some 256 MB of RAM, or also a very little amount of RAM you might be using inside a calculator. But when you come to the laptop, in the laptop you will be using i7 processors or also i5 processors, or also what else is I can say, right now a latest Intel processor came into the market, so you can use those kinds of Intel processors also, or else high power processors. And then you will have the RAM like 8 GB RAM, 16 GB RAM, or 32 GB RAM. Desktops are also available right now in the market. So when you see the desktop, when you compare the desktop or laptop with the calculator, there is a tremendous change in the resource configurations. Okay. Why? Because you have to run the multiple applications. You have to run the multiple applications. You have to work for yourself. You have to install so many different kinds of applications. So definitely there is the processing speed should be high, and as well as the processor should be processing at a very higher level to run all the applications, and as well as the RAM should be high to store all the application related data. So obviously, the desktop and laptop will be a little bit higher in the resource capacity when you compare with the calculator. But when you come to the server will have the huge amount of resource capacity, like some 16 CPU, 256 GB RAM, or else 512 GB RAM, like that. So why a server needs that much amount of capacity? Why? Because obviously inside a server you will run the multiple types of applications, and multiple more number of users will be interacting with that particular server. Not only a single user, there will be some thousands and lakhs of users who will be communicate every day communicating with the servers. So at that given point of time, definitely the resource consumption will be very high. So for example, I am the only one who is interacting with this laptop. So when I am the only one who is interacting with the laptop, so in the background, so many different kinds of applications will be running to support my requested action. So for example, if I want to run an application, to run that application, there will be different kinds of dependencies will be there. So all the dependencies has to run. So I am going to interact with this particular laptop at that particular time. Now, if you see here, how much amount of CPU and RAM consumption is happening. So 40% of CPU and 8 GB of RAM, 50% of the RAM is consumed. Okay. So only if a single person is interacting. For example, into this laptop, I have installed an web application. Just for your understanding, I'm saying I just installed a web application. So now what is going to happen? So for this laptop, I have given an IP address. So laptop, I gave an IP address, and that IP address I converted that IP address into a domain name, like just whatever the URL that you are seeing. So like www dot same kvb dot kvb.co.in. So this is the domain name which I have converted, whatever the web application. So I have given this URL to each and every student of mine, or else each and everywhere. So I did my advertisement. I did my, what I can say. So I ran my social media ads saying that this is what my website is all about, and you can just go through the website if you are interested towards joining into that particular corporation. So you can join. So that is what the advertisement that I am giving. So most number of the people, so everywhere, so what is going to happen? Everyone will try to access that application. Everyone will be trying to connect to this IP address. So this IP address will be connected towards my laptop. When they hit on this particular URL in the backend, that will be converted as an this IP address, and this IP address belongs to my laptop. So for example, 100 people are trying to connect. 100 people are trying to connect. My laptop will be trying to give the response to those 100 people. If 1,000 people are trying to connect, obviously it will try to provide the response to the 1,000 people. But if 1 lakh people are trying to connect, so there will be a what I can say threshold point for each and every device. So at that particular threshold point, obviously my laptop is going to hang out. And if that goes beyond 1 lakh to some 10 lakh, obviously my laptop is going to shut down. Why? Because it has gone beyond its level. So then it will not, then it will not be able to send the responses for all the customers. So obviously my laptop is going to shut down. So that's the reason there are some commercial servers, or else there are some commercial computing device. Those are called as servers. And there are some personal devices. Those are called as desktops and laptops. And there are some what I can say educational purpose devices, like a lightweighted devices like calculators are available. So now you are using only desktop, but for the commercial purpose, if there are some 10,000 people or 1 lakh people or 10 lakhs people are going to access an web application or going to access any application, then definitely we need to go for the servers. Okay, we are going with the servers. So what are the different kinds of servers that are available? Different kinds in the sense, I'm not talking in the perspective of manufacturers. When I talk in the perspective of manufacturers, you can see Dell servers are there, HP servers are there, IBM servers are there. Like that, there are so many different kinds of servers that are available who are going to provide the physical hardware for you. I'm talking in the perspective of what I can say in the perspective of usage nature. Okay, so there are on-premises servers, on-prem servers, and virtual machines. These are the two kinds. Okay, so what are these two different servers that are going to work? Why we are going to work with these servers? Okay, we will discuss about that. But before we go into that concept, do you understand what is going to happen here? Any questions? Any confusions? Anything that you want to add up for? You can just write on the chat box.
It's
Are
clear.
you okay? Are you able to catch up the speed, or else what's do you find out do you find out any difficulty with the speed, or else how you are feeling about this?
Good with the speed. That's fine.
Right. So now let us discuss about the on-premises servers. Okay. So what is this on-prem servers? On-prem servers in the sense, for example, you have a company. Okay. You have an what I can say infrastructure related organization is there. Okay, who will provide the infrastructure solution for the end customers. See, when I work for my previous organization, what we are going to do here is we will provide the banking solution for a different countries. I don't want to name the countries, but the point is we will provide the banking solution for the different countries. Now, the bank won't have the entire infrastructure, whatever the bank for which we are providing the banking solutions or softwares. For that bank, we don't have the infrastructure services. Okay, so now what that bank is going to do here is they are going to tie up with a different infrastructure vendor. Now, if you see, the bank is tying up with the two vendors. Who are the two vendors over here? So if you see here, this is the banking organization. So this bank will communicate with the technical stuff, or also what I can say, your application coding stuff within particular organization. So this is my previous company. Let us suppose say ABC company. Okay, so they will interact with this ABC company and request for the software solution, the banking team. So now this ABC company will do a proposal. So to install or else to run our software, we need, so for example, in the front end. So we will have the discussion whenever there is an application or else whenever there is a solution that we are providing to that particular bank, what we are going to do here is we are going to propose certain things. What are the things that we are going to propose here is, see, the front end we are running is Tomcat. And if you want to have the proxy, you need to have the Nginx proxy. We are going to have the solution like Nginx proxy. And then on the back end or else the runtime which we are using is Spring Boot application or Java application. And in the back end, we will be running with the databases like MS SQL or also Oracle. Okay, so these are the solutions these are the softwares that we need to install. So for these softwares or else depending on your traffic, depending on the traffic, we will propose the development servers. So for development purpose, we want the dev servers. Okay, and then for UAT environment, we want an UAT servers. These are the different servers that we need to have. And for the prod, pre-prod or else prod, UAT servers can be called as pre-prod servers, and then we will have the prod servers. So for all the servers, we are going to provide the infrastructure resource explanation. We are going to give the entire resource explanation. So each server should have this much amount of RAM, this much amount of CPU, this much amount of storage. So everything we are going to provide the list of configurations like that. Now, what banking team will do? This bank team won't have their own infrastructure. Okay, the bank team won't have the own infrastructure. What they are going to do here is they will tie up with some another XYZ company. They are going to tie up with some another XYZ infrastructure company, and that infrastructure company will provide the servers whatever we are requested for. They will provide the entire infra. Okay, it's like a private cloud. Okay. Anyways, so this is how the functionalities will happen. So this infrastructure company, what they are going to do is, depending on my requirement. So I will say that I want a development server. So they will provide us a development server where I say that, so we want some 16 CPU and somewhere like to run all our microservices and to run our application, we want some 256 GB of RAM. So they will provide us a server. They will provide us a server. So now on this development server, what we are going to do here is we are going to install all the applications, whatever the applications that we want. For example, now for the development server, I don't have three-tier architecture. I will do all the three-tier architecture into a single server. Why? Because we don't have any traffic. Why? It's just a development server. Only the developers will interact with the servers, not the external audience, not the external audience in the sense outside people won't be, outside customers won't be interacting with the development server. So what I will do here is I will take a single server and install all the application, all the Web3 tier applications like Tomcat or else Nginx and as well as Java and as well as Postgres. I'm going to install each and every application over here. Okay. So when I install and run the applications, this is fine. I don't have any problem with the development application, but there is a single problem here is when this server is not available, when the server is down, then any application will not be available for the employee. So either he cannot develop the web application or else he cannot develop the Java application or else he cannot check the Postgres database also. So nothing will be available for the end customers. Why? Because this is a single point of failure. So this is the main problem which I'm going to face. And not only that, so for example, if I want to do the load balance testing, so I can check out multiple servers I can create and I can check out the load balancing. For that, what I have to do, I need to go for another server which is cost effective. So I cannot go with multiple servers in the development environment. Even though if the bank is going to say that, okay, we will pay that, we don't have any problem. So then we will go with the multiple servers. But here the point is, again, we need to install all the software, whatever the softwares that are available, that are there in the previous server. I need to install all the softwares or else we can take an image. So that image is also very high high in size, very huge size image will be coming. Okay, so this is the main problem that we are facing with the on-premises environment. Not only that, so whatever the Java application that I have installed, so if I am going with an upgraded Java application, which means that the previous services which I have written, which Java services I have written is in Java 17. Right now, what is the latest Java version? Java 21 or any new version is available. When I am working, when I am working in the sense previously, when I had an interaction, when I had a project, I came to know that there is Java 21. If there is any new upgrade Java is available, yeah, Java developers. Hello, Java developers are there.
Chaitanya, I'm working on Java 8 only.
Sorry.
I'm working on Java 8 only.
Okay, okay. So 1.8 you are talking. Yeah.
Yes.
See, right now when I had an interaction with my client, okay, he said that we proposed Java 17, but you are still lagging behind. You are so behind that there are vulnerabilities in Java 17. Right now we are proposing Java 21. Okay, so yeah, so now I am fascinated to know that you are still using Java 8. Okay. Anyways, coming back to the point here. So, yeah, anybody want to say something? I heard some voice. Okay, no problem. So now, so in this server, I installed a Java version Java 17. Okay, Java 17 I installed and I'm running an application. Now what happened in the next upgrade? In the next upgrade, I am going with the Java 21. So now what I have to do, already I have the Java 17 installed and running. So now I need to uninstall that. I need to uninstall that and reinstall Java 21. So there is a theory in the development. I don't know whether it is right or wrong, but the theory is if you install an higher version, lower version applications will be running. But if you are installing a lower version of application and trying to run the higher version of applications, it won't be running. So now I have a Java 17 applications, Java 17 install and I'm trying to run the Java 21 code. The applications won't be run. So I need to remove the entire Java 17 and I have to install the higher version and then I have to run the application. This is something tricky for me. Why? Because there are so many dependencies which I have to change. There is so much amount of code that I have to change. So it is an headache for me. So I cannot do that. So even I have to go with the same version itself, or else I cannot go for an upgrade. But if there is a mandatory upgrade, then there is a very hectic task are going to come into my picture. So how we are going to overcome all these problems? How we are going to overcome all these problems in the sense whatever the on-premises servers that you are having, despite of these on-premises servers, you can go with the virtual machines. So right now we are in the development phase. For example, if you are in the development phase, you can go with the virtual machines. When you are going with the virtual machines, you can install, you can have a virtual machine and you can run the applications and all the things. Now, what is the primary difference between the on-premises environment servers or else on-premises servers to the virtual servers? Now, when you see the virtual servers here, first, let us discuss about the on-premises server. So, what is going to happen? You will go to the market. Okay, so you will go to the computer market like a vegetable market and search for the different kind of hardware. Okay, so there you will get somewhere like HP servers, Dell servers, or else IBM servers, and you will find out one of the one is the best and optimized condition. Optimized condition in the sense best pricing and as well as best hardware, so you will purchase that server, or else what you are going to do here is you will get the what I can say different kinds of resources from the different vendors also, and you can combine all those things. You can do like that also, but the best thing is purchasing from a single vendor. So I am going to purchase this server from the Dell company. Okay, so this is the Dell server, so which is of 16 GB of 16 CPU and 256 GB of RAM. Okay, 256 GB of RAM. Now, when I purchase this server, now what I will do here is, in general, on the on-premises environment, I will install it. And inside the server, I am going to run my operating system, okay, your OS. Either it might be Ubuntu, or else it might be Red Hat, or else it might be Windows. I will run any Linux operating system. I don't want to specify the distro. I'm just going with the Linux. Okay, one Linux operating system I'm going to install. Inside this operating system, I'm going to install all the dependencies. What are the dependencies, or else whatever the applications that you are having, Tomcat, and then you will have what I can say Java, and then you will have Postgres. Like that, I'm going to install all the things. Now I will run the server. So now what you need to understand here is, at any given point of time, the load on the server will be the same. Do you understand my question? At any given point of time, is the load on the server will be same, or else it is going to differ? For example, I made this server into the production environment. Just let us supposing I made this server into the production environment. In the production environment, is the load is constant, or else it is going to vary?
It's going to vary depending on the number of users accessing it, right?
Yes, obviously, it is going to vary. So at any given point of time, we don't have very heavy load on that particular application in the entire day. So the entire day will be varying. For example, previously I worked for this stock market companies. Okay, so where we have to handle some 600 servers, not now, somewhere like 2016 time. Okay, at that particular point of time, we don't have all these cloud infrastructure and virtual machines. And virtual machines are there, but we used to have some 600 servers. There are virtual machines are also there, and we have to manage all the 600 servers. So we will manage this stock market for an top class banking bank. Okay, I don't want to name the bank, but we will work for this NSE and BSE thing. Now, if you see here, whenever the what I say Sensex is going to start, or else whenever the day is going to start for NSE and BSE, so we have to start all the applications, and exactly we have to start the applications by 8:15. Okay. Of course, even though the market will open at 9 o'clock. Okay. So we have to start the servers at 8:15, and we have to check all the start the servers in the servers will be running. We will stop some applications. Okay. Those applications are not necessary for the end customer. So now what we will do, we will stop some applications, and we will try to restart some services and all the things. So now what we are going to do here is, we will make sure that each and every application, we are going to check each and every application is running correctly at 8:15. Okay, so now when we give the go ahead, then what is going to happen? Exactly at 8:45, there are some another pre-checks will happen, and then the live market will start. At the point of live market starting, so there is a huge load will be there on the servers. Okay, so when we check the CPU, we have to monitor CPU and RAM. Like we will do it manually at that particular time, like 2016, 2015, 2016 time. We used to monitor the CPU and RAM at that particular point of time. Right now, you are having so many different kinds of monitoring tools. Of course, at that particular time also, you are having the monitoring tools, but not this much space. So we used to do the manual monitoring, and we are going to check each and every application. Okay, so now whether it is running fine or not, working fine or not. But at that particular point of time, around 9 o'clock, the application has very huge amount of load where they are going to consume all the resources. Now, after 9:30, 9:40, 9:45, what is going to happen? The load is going to come down. So whatever the 90% or 80% of the load is there, the entire load is going to come down to some 20%. And from morning 9:45 to afternoon 3:45, 3:30, 3:45, the load will be similar, 20% won't be there. So the market closing time is at 4 o'clock in the evening. So at that particular point of time, obviously at from 3:30 to 4 o'clock, again the load will be very high, and we have to monitor that half an hour. So now if you see, the load is getting varied at a particular point of time. Not only that, if you see any e-commerce website also, when they have announced an big billion day sales or great annual festival sales, at that particular point of time, the load on the servers will be very high. So now what I have to do to manage that load, I have to install, or else I need to run the multiple servers. But one point that you need to understand here is each and every application won't consume all the resources, won't consume. For example, I install an Tomcat. This Tomcat might be using some 4 CPU or else 2 CPU, some 30 GB of RAM or some 16 GB of RAM. That's it. And if you see the Java microservices, each microservice will consume is one CPU and, for example, 2 GB to 4 GB of RAM. Apart from that, it is not going to consume very high. If you are having some 30 services also, then 30 into 4, somewhere like 120 GB of RAM. If you are having some 30 services are running. So I'm talking this microservices at the peak time. Okay, so and then you are having the Postgres SQL which is running, so it is also not going to consume huge amount of resources. So now what you need to understand here, even though there are multiple applications that are running at any given point of time, at some time they will be utilizing the entire resources, but the rest of the time the application will be into the ideal state. Then there is a problem here. What is the problem? So the problem is if I purchase the multiple servers, so the purchase cost is very high. So I cannot purchase multiple servers. Then what I have to do? What is the solution for this? The cost, the price or else the money which I am putting on the infrastructure is very high rather than the money which I am investing on my application. So I cannot do that. So now what I have to do? So to overcome this problem, what has happened? So in the earlier 2000s, they have introduced a new concept. In the IT world, there is a new concept was introduced that is called as virtual machines. So we have introduced with the virtual machines where we are going to purchase a single server. Okay, so in the single server, in the single infrastructure server, we are going to run. So this is my what I can say Dell server. Okay. So which is of some 16 CPU or somewhere like 24 CPU, 24 CPU and 256 GB of RAM. Okay, so this is the hardware which we are going to get. On the top of this hardware, we are going to run the multiple virtual machines by installing a virtualization software. So there is some virtualization software, for example, VMware ESXi, it is one of the virtualization software which we are having. Or else Citrix Gen servers, Citrix, or else Hyper-V. So these are all the different kinds of virtualization applications that are available in the market. So we are going to run the application virtualization application. On the top of that, we are going to run the virtual machines. So I'm going to create a virtual machine. So this virtual machine is the web server. Okay, this is the web server which I am going to provide some 1 CPU or else 2 CPU, some what I can say 16 GB of RAM. That's more than enough, and I am going to install the Tomcat. Okay, Tomcat. Now I am going to install one more virtual machine in the same physical hardware. I am going to install one more virtual machine, and this virtual machine I am going to run multiple microservices, Java microservices. So this is my application server, which I am going to give 8 CPU and somewhere like what I can do 64 GB of RAM for running the Java services. Okay, so Java. And then I'm going to create one more virtual machine. So each virtual machine will be running its own operating system. And this particular virtual machine, I can run the database. Okay, DB server. So here for this server, I'm going to give some like 8 CPU. And for database, we don't require 64 GB of RAM. Why we are giving 64 GB of RAM for the application server? Because of the multiple microservices that are available for that particular application. But when you come to the database server, I will go with the 16 GB or else let us supposing 32 GB of RAM. 32 GB RAM. That's more than enough for the database. So now if you calculate here, 32 plus 64, 96 plus 16, somewhere like 112 GB of RAM is there. So I will install the Postgres or I can go with the some another MySQL or else MS SQL database. So all these three are interconnected with each other, and they are available in a single physical server. And this is the virtual machine. So this virtual machine, now what is the main difference between the physical server and the virtual machine? So whenever you want to take the image backup, you can take the image backup snapshot at any given point of time. You can take the snapshot. And if the virtual machine is not properly running, you can remove that virtual machine and you can easily recreate another virtual machine also. That can be done. So there are so many different kinds of advantages that are available when you come to the on-premises environment. Now, if you see here, all the applications are running on a single server. So if the server is down, then the applications won't be available for you. Of course, the same case will be happen over here, but the point is, for example, if the Tomcat server, there is a problem with the Tomcat server, so you don't need to down all the remaining services like application server and database server. So simply you can check with the that particular virtual machine, whatever the Tomcat virtual machine or web server virtual machine that you are having, you can just check out that virtual machine and find out the problem and resolve the issue. Until then, the application servers and database servers will be connected to another web server. Okay, so the same clone of another web server will be there. So to that web server, this application server and the database server will be connected, and the end users won't have any kind of problem. So now what is going to happen? The flexibility will be there. When you compare with the on-premises environment to the virtual machines, you will have the flexibility, cost effectiveness will be there, cost optimization will be there. So that is the reason why we are going for the virtual machines. Got the clarity? Any questions?
It's clear.
Everyone?
Yeah, it's clear. It's clear.
All right. So now we are having this virtual missions. Now then why we are going for the Docker containers? Now this is the main core point that we have to go through. So we have to, from tomorrow onwards, we are going to start the containerization. So everyone has to understand why we need to go for the containers as we are having the virtual machine. The main point here is these virtual machines, whichever you have created, every virtual machine will have an guest operating system should be installed. For example, to run this web server, I need to install the Ubuntu operating system or else Red Hat operating system. For Java, I need to install again Ubuntu or Red Hat. For Postgres, again, I need to install the Ubuntu and Red Hat. For example, I'm telling. Okay. So if you install an operating system, you need to, so with the operating system, kernel will be installed and lots of packages will be installed. So, and after that, after installing the operating system, you need to install all the dependencies for that application, and then you have to implement your code, and to run that code, you need to install all the dependencies. And when you pack this entire operating system, if I want to move this entire code, or else if I want to move the servers, okay, if I want to move the servers from one environment to the another environment, okay, so from one particular environment like development environment to the production environment or else UAT environment, it's a huge task for me. So I have to convert the each and every virtual machine into an image format, which is going to come somewhere like, if that is a very light machine, you are going to get some 30 to 40 GB of storage space is going to consume for each and every virtual machine, and then I have to move that image to a production virtual VMware and production virtual servers, and then I have to unzip it and I have to load it, which is going to take lots of time. Sir, why we need to do all these things? So one thing that you need to understand here is, I might think there are so many developers, they know about this problem. So you will write certain code in your laptop, you will write the code and say that the code is working fine in my laptop. Okay, so the application is fantastically working and all the functionalities are working. I don't have any problem, so I can release it to the development environment. Okay, so now what you will do, you will upload the code into the GitHub. Okay, you will upload the code into a version control and say to the DevOps engineer, I have uploaded my code into the GitHub. So now what DevOps engineer will do? Okay, let us see what I can do. So he will pull down the code and run the maven clean package or maven clean install. But at that particular point of time, what is going to happen? The code build will be failed. Then you will have the mail exchange. The build is failed. there is a problem with your code. Now you will say that in my laptop, the code is working fine. In your laptop, you are going to install all the dependencies as per your requirement. But when you come to the servers won't be like that. Okay, so already in the servers, you will have the pre-configured installations will be there. So then there will be a fight between the development team and the operations team, obviously. So this is what I find out everywhere, but no offense. But the point is, this is what going to happen. Okay, so the application will be running in your laptop and the same application won't be running in the server. In the same manner, if that application is running in the development environment, so you can ask the operations team to install all the software as per your requirement. So the operations team will install all the software as per your requirement. So the application will be smoothly running in the development environment. But when you go to the production environment, there you will get a failure. Why? Because production servers are running fast from 10 years back onwards. So they will have only that Java 8, Java 11 versions or else Python 2 versions. So now currently Python 3.8 is running. Currently Java 21 is running. So it is not like that. So your applications will not support the older versions. Now there comes the problems. Okay, so to resolve that issue, what I have to do, I need to pack the entire virtual machines and shift the virtual machines into an production environment, unzip the virtual machines and create the virtual machines in the production grade, and I have to allow the traffic. So there is a lots and lots of time is going to have taken place. So this is the main problem with the on-premises and virtual machines. To overcome all these problems, whatever the problems that you are facing, either it might be fluctuations in the load, or else it might be cost optimization, or else service resource utilization, and whatever the time taking for you to convert from one environment to the another environment, to move your code from one environment to the another environment, there is a single stop solution for that, and that solution is containers. That solution is the Docker, and that solution is your containers. And what is this containers? How we are going to work with the containers and what we are going to do with the containers, we will see in the next session. Okay. I hope this session will be helpful for you. It is a help anywhere a little bit for you to understand why we need to have the containers, what is the on-premises servers, what is the virtual machines, what is meant by a container. So, but still, we didn't study about the containers. We will see about the containers in the next session. But excuse me. But I hope this session helped you a little bit to understand towards your containers. It will take one step ahead for your understanding towards the containers. Okay. So we'll discuss about the containers in the next session. If you have anything to ask me, you can ask me now.
Yeah, Chaitanya, actually, I want to know the course duration and what is the duration of the work session? It's a 1 hour, 2 hour?
It's a 2 hour session. So from 7 a.m. to 9 a.m. mostly. So yeah, or else we will prepone that like 6:30 a.m. to 8:30 a.m. also. Right now, I'm thinking of going with 7 to 9. But there might be some working professionals who has gotten the calls at 9 a.m. So
It would
my
be a little better if you post one.
yeah, I totally agree with you. But right now, we will go with the 7 a.m. only. So as of the demo, we will go with the 7 a.m. to 8 a.m. So once we started with that course, we'll see whether it is possible to make prepone like 6:30 a.m. If it is possible, I will try to prepone the session at 6:30 to 8:30 a.m. Or else we can extend another half an hour also. It is not a very big deal. So 2 hours of session will be there, and we are going to cover the entire course by 20 days mostly. My agenda or else my tentative date is already I said you April 7th, or else it might be April 14th. Am I clear?
Yeah, okay. And it's a better to prepone. It's a 6 a.m. It's fine for me, I think.
No, not 6 a.m. 6 a.m. is not at all fine for me. I have an US batch at 5:30 a.m. Not possible.
Okay.
So
Okay, 6:30 is fine now?
6:30 is fine for me.
Yeah,
Let me
okay.
check with that. 6:37. Why? Because there are another sessions will be conducting. Might be. Let me check out all the timetable schedule and everything. But my feasible timings will be like 6:30 or 7. Okay. We'll see what we can do with that.
7 to 9 is fine, right?
Yeah, I'm not saying I am going to start the session at 6:30. Okay,
Mhm.
so there is an option that is available. We will see about that.
Okay.
Right.
You're good with 7 to 9 actually.
Yeah, seven is better, Chaitanya.
Fine. Then. We'll discuss. We'll see that. Okay. But still, we are into the demos only. We are not in deep into the main content. So once the demos are completed, we will start the session. I will give you the exact timing at what we are going to start the session. Don't worry about the session timings, but please concentrate on the subject only. Okay. Yeah. Anything else?
Yeah, it's a weekend is also class is there
Weekend
or
classes will be there. Weekend classes will be there. It's not like see, it's a very comprehensive topic where we are going to cover. We have a tight lines. So I don't want to make you feel that exhausted for 40 days. Okay, if I have to take the Kubernetes session, I can take it for 40 days also, but you will be exhausted for that. So I don't want to make you feel that. So I want to make you feel fresh at any given point of time. For that, I am going to conduct it for 2 hours of session, and it will be an everyday session.
yeah, okay.
Right?
Yeah.
Chaitanya, this is Munish here.
Yeah, Manish.
I am looking for the transition from BPO to, DevOps. I had a 10 years experience in the BPO sector.
Okay.
Can, can I do the transitions after this course by keeping the 10 years experience as a related?
But the point is that cannot be considered as a real-time experience, Manish, even though you are having 10 years of BPO experience.
Okay.
Okay. So if you want to do a transition, it will be handy for you. Of course, so whatever the salary that you are earning, so you can ask for a very good hike also by completing the entire DevOps course, not the Docker and Kubernetes. Okay. See, I'm talking in the perspective of your career. So if I have to say, I can say that yes, you can do this course and you can do a transition, but that won't help your career. Okay.
Okay.
So with what will help your career is start learning from the cloud. Okay. AWS, DevOps, Kubernetes. This is the flow. Okay. So if you jump on directly to the Docker and Kubernetes, you cannot do that. No, I won't say that you cannot do this thing. Okay, I can say that you can do this. But the problem is, so the other persons, whoever are working, the other candidates or other students, whoever are working for 1 year, for 1 hour, you have to work for minimum 2 to 3 hours. You have to do the practice for 2 to 3 hours, and then you can do that. Okay. So that's the criteria over here. If you have a prior knowledge about the cloud or else any DevOps, so again, there are so many people will ask me that, sir, we don't have any knowledge. At least they are working with the what I can say IT environment. Okay, so they are the developers and they are working with the IT environment. So now you are transitioning from directly from BPO to directly into the IT. So then you have to work hard. Okay. Right. So again, saying you that if you want to join, we are welcome. We don't have any problem. But the point is, by looking into your career, okay, by looking into whatever the transition that you want to do, so first learn the basic. Sir, no, sir. I will cover the Docker and Kubernetes. You are welcome to cover the Docker and Kubernetes, but at least after covering the Docker and Kubernetes, you need to cover the DevOps and AWS, or else Azure. Right.
Yeah, one more question I have.
Yes, buddy.
Yeah, actually, I don't have too much idea on AWS. Just introduction, but I gone through that AWS. So it's better for me to join this course or not?
Yeah, it's better for you. You are a developer, right? So
Yes.
no problem. You can join.
Okay, thanks.
Yeah. Anything else?
One question about practice, actually. So practical part. So how much will be the practical part wherein we we do the hands-on kind of labs that we
Everything is a practical only.
okay.
It's 90% of practical will be there. 90% your hands-on. So you have to do that. Okay. Only 10% will be the theory. Why?
Okay.
So, which means you are not going to tell the theory. No, it's not like I am not going to tell the theory, but I am going to tell you the theory in the practical manner. Okay.
Okay.
So if I say a container, okay, when I say a container is a process which will run the application. So that is a theory. It's done. Container is completed for you. But if I say this, you won't understand that, right? So I have to show you in a practical manner that this is how the containers will work. Then only you will understand. So
Right.
whatever the words that I am saying, I will try to explain you in a practical manner, each and everything. Okay, I will try to show you each and everything in the practical thing. Then only you will be able to understand. Then only you will be able to cope up. Otherwise, you will be standing behind. I will be going forward. Okay. So it's day to day, every day you will have the practical, you have to do the practice. Clear?
Yeah.
All right. Anything else? Anything, guys?
No from my side.
Okay. Nursing Yadav, Mahendra,
No questions from my side, Chaitanya.
that's fine. Subhash, Ram, Prashant.
No, we are good.
No, nothing.
Okay. So I hope everything is clear from my end. So have a nice day and we'll meet in the next session. Tomorrow is the last and final demo of your Docker. So if you are thinking it's a demo, so it's a last demo for you. Anyways, we are going to start the containers from where the containers have originated, how containers will be running. So everything will be there in the next session. And from day after tomorrow, those who have enrolled for the course, they will be attending to the session and we will share the videos for those people who have enrolled for the session. Okay. So have a nice day and bye-bye.
Thank you.
Thank you.